Hey everyone, welcome back to the channel. In today's video, we are diving deep into two popular ensemble learning technique in machine learning, the bagging and pasting. These methods are crucial for improving the performance and accuracy of your machine learning model, especially when dealing with unstable algorithm like decision tree. We'll walk through both methods, their key difference, and importantly, show you how to implement them with real life example and code. So before we dive into code, let's break down both concept behind packing and pasting. So first, packing or bootstrap aggregating is an ensemble method where multiple versions of a model are trained on different data set of the data. The key idea here is sampling with replacement. This means that for each new model, we randomly select data points from the original data set, but some of them might be repeated and some might be left out. After training each individual model, we combine their prediction, typically through voting for classification and averaging for regression. The goal is to reduce variance and overfitting, especially for high variance model like decision tree. And what is pasting? So pasting, on the other hand, is very similar to bagging with one important difference. Instead of sampling with replacement, pasting sample without replacement. In other words, each individual model is trained on random subset of the data, but no data point can be selected more than once. Pasting still involves combining the prediction from multiple models to improve performance, but because each model gets a unique subset of the data, it might lead to slightly different outcome compared to bagging. And to summarize the key difference, in bagging we sample with replacement. This means some data point might appear more than once in a subset. In pasting, we sample without replacement. Each data point is unique in each subset. Bagging tend to be more effective at reducing variance because of this random duplication of the data point, whereas pasting may still help reduce overfitting, but might not be as powerful when you are using the model that have high variance like decision tree. Now let's get into the examples to compare how bagging and pasting affects model performance, and we'll use a simple decision tree classifier and the famous iris dataset. We will compare how both techniques perform using bagging and pasting, and which we will visualize the results. So let me import the libraries. Here we are using the same scikit-learn, and next let me load the dataset. And now let me split the data into test and train, and let me initialize basic decision tree classifier. And let's first create a model for a bagging model with the estimator as base model and fit the model, right? And let's create y prediction using the x test, and let's calculate the bagging accuracy. And the final to compare confusion matrix and classification report for bagging, creating these two variables. Similarly, we'll run the code for pasting. Same code. Only difference here, the bootstrap is full. So that's the main difference between this code and the above. Everything remains the same. We calculate the accuracy. We have the confusion matrix, and we'll display the result. So in this case, because data set is very small, we'll get the accuracy of close to 1 or almost 1. So till now, we loaded the iris dataset. We initialize the decision tree classifier, and both the models are trained using bagging classifier from scikit-learn ensembles. The bootstrap parameter control whether we are sampling with replacement, means bagging, or without replacement, pasting. And after training, we make a prediction on the test using both bagging and pasting. And when we compute the accuracy, confusion matrix, and classification report to assess the performance. Right. So as you can see, the accuracy is both 100%, as I said, because of the small data set, and this will also has the similar result. And to view the classification report, we have precision recall, FN score, and support. Similarly for the pasting. And let me do a cross-validation comparison between these two. So to get more robust evaluation of the model, we perform five-fold cross-validation using Crosswell score and print out the mean score of both the models. And this gave us an estimate of how well the model generalized to unseen data. Next one is the uh, bar plot. So this is to compare the accuracy of both the bagging versus pasting. And the final plot I would like to show is the decision boundary. So this is the code of plotting the decision boundary. And so we plot the decision boundary for both the models using only the two features of the array dataset. And this helps us to understand how the model partition the feature space. So decision boundary show how each assemble method learns and classify data. So this one is the decision boundary for bagging, and this one is the decision boundary for pasting. So to summarize, this code provides the very comprehensive comparison of bagging and pasting, including model training and both with both the techniques, evaluation, visualization, and we also use the cross validation to assess generalized performance. Yep, that's it for today. Thank you for watching. See you the next time.